This is a piece of copper wire you picked up. You take out the copper core, then find an iron rod. You connect them with wires to a small LED light and place them into salt water. Suddenly the LED lights up. What is happening here? You probably remember metal reactivity. Iron is more reactive than copper. Iron loses electrons and becomes positively charged. Copper gains electrons. Electric current flows in the opposite direction of electron movement. So electrons flow from iron to copper. At the copper side, the electrons react with oxygen and water, forming hydroxide ions. Meanwhile, iron forms iron ions and enters the solution. These ions react with hydroxide ions. Because of this process, electrons keep flowing from iron to copper, producing current. But after a few minutes, the light goes out. You take out the copper rod, wipe it, and put it back. The light turns on again. This happens because hydroxide ions and small amounts of copper ions form copper hydroxide, which sticks to the copper surface and blocks electron flow. Is there a way to avoid wiping the copper repeatedly? Yes. You get a new metal rod and replace the salt water with dilute sulfuric acid. Now the LED is brighter, meaning the current is stronger. This time, copper doesn't get blocked, because the electrons combine with hydrogen ions in the acid to form hydrogen gas, which escapes. The new metal reacts and forms soluble compounds in the solution. Now it seems like it can keep generating electricity forever, but after a few hours the light goes out again. You notice that the new metal rod has been half consumed. So, to keep it working, you must keep replacing the rod. Is there a material that can be reused and still produce strong electricity? Yes. You take two plates, one coated with lead dioxide, positive, and one made of lead, negative. You place them in dilute sulfuric acid and connect them to a circuit. Now the current is strong enough to light a bulb. Here's what happens. At the negative plate, lead loses electrons and becomes lead ions. These react with sulfate ions to form lead sulfate. At the positive plate, lead dioxide gains electrons and reacts with hydrogen ions and sulfate ions, forming lead sulfate and water. The sulfuric acid becomes less concentrated. Both plates slowly get covered with lead sulfate. This continues for hours until the reaction stops and the light goes out. Now you connect the battery to a power source to charge it. During charging, the lead sulfate on the positive plate loses electrons and turns back into lead dioxide. The lead sulfate on the negative plate gains electrons and turns back into lead. The sulfuric acid concentration increases again. Both plates return to their original state. Congratulations! You have invented the lead-acid battery. It can convert chemical energy into electrical energy and back again, so it can be reused.